In this video, we are going to talk about token standards, and the first token standard which we will be covering is ERC-20. ERC-20 tokens are also known as fungible tokens. Let us understand what is an ERC-20 token. It is the standard for currencies and ICOs. Here ICOs stands for initial coin offerings. Similar to IPOs, whenever a crypto company wants to go public, they can conduct ICOs. ICOs is a way to generate money for the business via the use of cryptocurrencies. Again, ICOs stands for initial coin offerings. ERC-20 or Ethereum request for comment 20 is the token standard that defines a common interface for fungible tokens. It defines a common interface for fungible tokens. All tokens following this standard are interchangeable. That means 1 USDC is equal to 1 USDC. If there is a token, let us say that token is DAI. If this DAI token follows ERC-20 standard, that means it is interchangeable. When we say it is interchangeable, they can exist in multiple quantities. Since the same token can exist in multiple quantities, hence they are also called as fungible tokens. So ERC-20 stands for Ethereum request for comment 20. It is a standard that defines a common interface for fungible tokens. Now comes a question, when can we say a token contract is ERC-20 compatible? Or let us say I have deployed a token, my token, what are the conditions that my token must follow in order for it to be ERC-20 compliant, or I can call that as an ERC-20 standard token. So to answer that question, the my token contract must have 6 required functions plus 2 events. It must have 6 required functions plus 2 events. Now what are those functions? The first function is total supply. It is evident from the name itself. Total supply is equal to the total number of tokens that will be available at any given point of time. The function signature is total supply. It returns an unsigned integer 256. It returns the total token supply. Balance of, it returns token balance of an address. If you hold 1000 of my tokens, in order to query that, we must call balanceOf with your wallet address, which will then return an unsigned integer 256, which will be equal to 1000. Then we have transfer function. In order to transfer the tokens from your account to somebody else's account, your token contract must implement this transfer function. Now this accepts 2 parameters. First is address to, sometimes also referred to as the receiver, and the amount that you wish to transfer. Now this function returns a boolean which says whether the transfer was successful or not. So it is used to transfer tokens from caller to the recipient. Then we have allowance and approve. Now allowance and approve, both of these functions are very important. Whenever you want somebody else to spend your tokens on your behalf without sharing your private key, that time these two functions kick in. So what does approve do? It approves the spender to use up to the amount of tokens. That means, let us say spender is Bob and Alice is approving Bob to spend 1000 tokens on her behalf. In that case, Bob can spend at max 1000 tokens from Alice's address. Now this is possible because Alice has called the approve function setting the address of Bob as a spender. Now how to check the approval amount? That can be checked using or calling the allowance function. So here when you invoke the allowance function, it takes 2 parameters. First is the address of the owner, second the spender, and it returns an unsigned integer 256, which is nothing but the amount which Alice has approved to Bob via the call to approve function. After this, we have the transferFrom function. So we have said here Alice has approved Bob to spend 1000 tokens on her behalf. But how exactly can Bob do that transfer? Bob can do that transfer by calling the transferFrom function. Now inside this transferFrom function, Bob will specify from address to be that of aliases, then to the address of the receiver and the amount. But note, Bob can transfer at max 1000 tokens since Alice has approved Bob to spend only 1000 tokens. If Bob tries to move or transfer tokens greater than 1000, then this function will fail or this transaction will fail. So we have seen the 6 different functions. In order to make any token contract ERC-20 compatible, those are total supply, balance of, transfer, allowance, approve, and at last transfer from. After this, we said your contract or the token contract must also include 2 events. Those are transfer and approval. Whenever you call transfer function, when the transfer is successful, at last from within this function, this transfer event is emitted. And whenever you call approve, and upon successful execution of the approval transaction, at last, this approval event is emitted. Hence, what we have covered, we have looked into what ERC-20 is. ERC-20 is a standard which makes all the tokens following it interchangeable. Then, in order to make a token contract ERC-20 compatible, it must implement 6 functions and 2 events. We have seen what those 6 functions are and what those 2 events are. Now let us go ahead and look into the actual code of the ERC-20 contract. Before we begin, let us skim over ERC-20 interface. ERC-20 interface. So we have said in order for a token contract to be ERC-20 compatible, it must implement 6 functions and 2 events. Now we have added those inside this interface ERC-20. Key takeaway at this point is the approve and the transfer from these 2-step pattern is how DeFi protocols access your tokens. Consider Uniswap, SushiSwap, PancakeSwap, or any DeFi which is available in the market. They are able to access your tokens only because of these 2 functions. You approve the protocol to spend tokens on your behalf. The protocol then internally calls transferFrom in order to spend tokens on your behalf. If you remove approve and transferFrom, it is as good as no DeFi protocol will exist. You approve Uniswap to spend your USDC, then Uniswap calls transferFrom to take exactly what it needs without ever holding your private key. Going ahead, here we are implementing a simple ERC-20 contract based on the learnings or the theory which we have covered so far. So here in this slide, you can see we have defined our contract as ERC-20. Now this ERC-20 is inheriting from IERC-20. Now this IERC-20 is defined over here, which has 6 functions and 2 events, and we have said if your token contract can be ERC-20 compatible if and only if it implements the 6 required functions and the 2 events. Now these are the state variables. First is the name of your token, the symbol of your token, decimals is by default set to 80. Then at last you have the total supply. Then we have 2 mappings. First is balanceOf, second is allowance. Allowance will be populated when approve function will be called. balanceOf is used to query the balance of a given address for a particular token. And inside constructor, we are setting the name and symbol for our ERC-20 token or ERC-20 token contract. This name and symbol is passed during deployment, and that will be assigned to the state variables name and symbol. Going ahead, we have the transfer function. Now this transfer function is used to move funds from the sender to the receiver. This takes two arguments or 2 parameters. First is the to address, sometimes also referred to as recipient, the amount that you wish to transfer. So first here we are checking This to address must be a valid address. It should not be address 0. So if that turns out to be a 0 address, your transaction will be reverted with the reason 0 address. Then we are checking the balance of message.sender, or we are deducting the amount from the sender's account. The sender's balance is stored inside this balance of mapping. Hence, and message.sender is nothing but the caller of this transfer function. So if Alice is calling transfer with the address of Bob, specifying the amount to be 1000, in that case, balance of message.sender, this message.sender will be replaced by Alice's address, and then the balance of Alice, let us say if it is 1500 and she's trying to send 1000 tokens, in that case, out of 1500, 1000 tokens will be deducted, and then balance of 2, that is Bob's address, that balance will be added into Bob's address. Once this is done, it will emit a transfer event and then return true. Here we have a statement, it reverts if insufficient. What does it mean? After Solidity compiler version 0.8.x, it can be 0.8.0, 0.8.1, 0.8.2 or any compiler version, handles overflow and underflow automatically, or overflow or underflow handling is directly inbuilt into the Solidity compiler after version 0.8.x. Prior to 0.8.x, we were using, or there was a need to use safe math library to catch overflow or underflow errors. Hence, a comment has been added over here. It will revert if insufficient. That is, if Alice is trying to send 1000 tokens and her balance is 500 tokens, so that this will result into underflow, and from here the transaction will be reverted. This will be reverted only in case of Solidity compiler 0.8.x. Now after transfer function, let us take a look at the approve function. In case of approve, we are passing the spender address and the amount the spender can spend. So first, here we directly update the mapping, which is allowance mapping. It is a nested mapping. Message.sender is the caller, or say Alice wants to approve Uniswap to send tokens on her behalf. So message.sender will be Alice's address. Spender will be Uniswap's address. The amount that Alice is willing to approve or give approval to Uniswap to send on her behalf. After updating the mapping, we emit an approval event and return true. However, here one check is missing. Prior to updating the allowance, we should have, or we must have checked address of spender is not equal to address 0. Address of spender is not equal to address 0. However, we have not done that on purpose, because here the idea is to understand ERC-20 standard and its different functions and the events. So we have covered so far transfer, approve. Now let us look into the transferFrom function. In approve function, we said Alice has approved Uniswap to spend 1000 tokens on her behalf. Now Uniswap can call transferFrom on Alice's behalf and can spend at max 1000 tokens from her account. How is that done? Uniswap will pass the from address to be Alice's address. 2 will be, let us say, the router contract. Amount is 500. First, it will deduct the allowance. So allowance mapping will be subtracted by amount 500. Since Alice has given approval of 1000 tokens, now it has come down to 500 tokens. Once the allowance is deducted, then the balance will be deducted. After that balance is deducted from Alice's account, and balance of 2, here 2 is the router contract. So 500 tokens will be added to router contract, and after completion of this, an event will be emitted, which is a transfer event. It will go from the from account to the to account and then to the amount account, and then the amount. Then at last we have mint and burn function. Here if you see, if we scroll up, inside constructor, we are only setting the name and symbol for the token. We haven't set the initial supply. we haven't set the initial supply. Now that initial supply could be sent from within the constructor by calling the mint function. This is an internal function. This cannot be called from outside the contract. So we can call this mint function from within the constructor, sending the address of to be message.sender or the account which is deploying the contract, and will set the amount to be say 1 billion. So what it will do, it will increase the total supply to 1 billion. It will update the balance of 2, that is the account which is deploying this contract, to 1 billion, and then it will emit a transfer event. Here if you notice, the signature of transfer event is, it has from, to and the value. Well, let us scroll down. In case of mint, always remember, in case of mint, since we are generating tokens or minting tokens, these tokens are not assigned to some other wallet, or these tokens are not coming from some other wallet. Hence, when we mint, the transfer event functions from address is address 0, because we are creating tokens out of thin air. Hence, in case of mint, the from address for event transfer is address 0. And in case of burning the tokens means destroying the tokens. Now, when we destroy the tokens, those tokens have to be subtracted from the total supply. The account which is calling the burn function, its balance has to be deducted, and at last the transfer event must be emitted. If you notice the transfer event here, we are sending the token. When we say we are destroying the token, in that case the to or the receiver becomes address 0. So in case of mint, from is address 0 for event transfer. In case of burn, to is address 0 for event transfer. So first we looked into 6. What can make an ERC-20 contract, a token contract, ERC-20 compatible? 6 functions, 2 events. We defined an interface with 6 functions and 2 events. Then we created a simple contract, ERC-20, implementing those functions which haven't defined in the interface. This is the overall idea about ERC-20 smart contracts. But the most important thing to remember here is the approve plus transfer from. This 2-step pattern is how DeFi protocols access your tokens. DeFi protocols, or it can be another externally owned wallet, it can be another smart contract, or it can be anything. If you want somebody else to spend your tokens on your behalf without ever holding your private key, then approve and transfer from are inevitable. Approve and transfer from, these 2 functions make possible the spending of your funds on your behalf without holding your private key. This should be remembered. So in the next video, I will be implementing the same contract and deploying it on the local hard hat network. So we have covered the theory part. In the next video, I will develop the ERC-20 contract, compile it. After compiling, I will deploy the same ERC-20 contract onto the hard hat network. So thank you all for your attention. I hope you have learned something valuable today. If you have learned something and you find our videos useful, please like, share and subscribe our channel. Also, before going, one important point is, this is you could say syntax errors. So you have to replace %GT with greater than symbol. This %GT will be replaced with greater than symbol. So these are syntax errors. If I copy paste this contract as it is, it will not compile, specifying compiler errors at this point. So thank you all for joining today, and I'll see you in the next. Thank you.